Well, hi everybody. Welcome to this first IoT webinar. I'm here with a couple of speakers and Yorick Intel representative. So my name is Alex from Be My App. We organize this webinar with Yorick. I'm really happy that to see many connection here on this webinar. So I can definitely see that there is a lot of interest on the Intel Edison platform. So just just before to give the presentation to Yorick, I'm going to give you a few technical details regarding the technology. So feel free to ask question on the chat panel. All right. So on the GoToWebinar dashboard, you have the opportunity to ask question. All right. In live along with Yorick, there is Dirk Rosier. Okay, who is here to answer your technical question. Okay, so feel free to interact. We are here to answer to your question and present you very nice project. So also, if you have any feeling about the technology, please send us a tweet on hashtag #MakeItPro. Okay, just share some feedback or feeling you have. And that's pretty much it. I hope everybody has a clear sound and a clear video as well. If not, please let us know. Okay, we'll try to figure out what happened. Yorick, are you here with us?
Yes. Hi, Alex.
Okay.
Thanks for the introduction.
Go ahead.
So, hi everyone, and thanks for joining us for this IoT Innovation webinar. So my name is Yorick Shedgin, and I work for Intel. I'm in charge of the EMEA activities around IoT inventors and makers more generally. So in today's webinar, we will start with an introduction to the IoT environment, how it looks today, and then go through some of the details of two innovations out there. The first innovation is around home automation, and that will be presented by Nathan. And the second innovation by Patrick walks us through the use of Intel Edison as a robot control device. We will then wrap up and provide links to more information on these topics. So the Internet of Things is a massive opportunity. I don't think anybody out there debates this. If you look at some of the numbers, IDC is reporting 15 billion connected devices this year, and an exponential growth of up to 50 billion connected devices within the next 5 years. So these connected devices touches every segment of the market, from consumer to industries. Home automation, healthcare, industrial sector, smart cities, transportation. These are just a few examples of the sectors in which IoT can bring valuable transformation. So the interesting part to me in this whole movement is to look at the innovation process and also more specifically at where the innovation is coming from. There was a time where a lot of the innovation was coming from large established companies. Those large enterprises are definitely still innovating, but there's a major trend out there for startup inventors and entrepreneurs of all kinds to fuel more and more of this innovation. This trend is driven by the accessibility of component and building blocks necessary to innovate. And you can look at it from different angles. If you look at the software, if you look at it from a software perspective, you have higher level development tools. From a hardware perspective, you get cheaper and more accessible compute platforms, or things like 3D printing. You can also look at it from a financing perspective with access to crowdfunding platforms, or even from a go-to-market perspective with the availability of online sales tools, making it easy to go to markets. So all these elements are reducing the barriers for inventors to innovate and bring those new ideas to markets. So what are we doing as Intel to support inventors in this environment? If you look back at 2013, we introduced a product called Galileo, which is an Arduino-compatible compute platform for quick prototyping. Now in the second half of last year, we also introduced a new product called Intel Edison Development Platform. The objective here is not to provide a full product training of this platform, but I did want to highlight a couple of points before I hand it over to Nathan and Patrick. The Intel Edison platform it's a full compute module in a very tiny form factor. It has dual-core CPU with 1 gig of RAM. It has 4 gigs of storage on the board. It has embedded connectivity with Wi-Fi and Bluetooth. And finally, it has a microcontroller element allowing to connect to all the sensors through 40 GPIOs. The interesting part about this is really the size and the form factor of this compute platform, because all of these functionalities are provided in something that is about the size of an SD card. So the purpose of this obviously is quick prototyping, like we could do with something like Galileo, but then you can also move your prototype into a production-ready solution by using this same Edison development platform. So along with the compute module itself, there's a couple of expansion boards available out there. There's 2 expansion boards provided by Intel. The first one is a kit with the Arduino expansion board. So this provides the easiness of the Arduino environment for really very quick prototyping. The second one is a kit with the mini breakout board, and this one is really sort of the next stage in the development, and that allows to really take full advantage of the size of the Edison compute module. In addition to that, there's a couple of partners out there that bring a whole suite of expansion boards to bring additional capabilities to the Intel platform. And also, we've seen a couple of customers actually starting prototyping, moving to something like the mini breakout board, but then eventually building their own optimized PCB for Intel Edison, and then bringing their developed product to market with this. So with that, we're always open to questions, so there is the chat for further question on the product, but I did want to hand it over to 2 of our innovators out there, and I believe Nathan is the first one here. Alex, can you hand it over to Nathan?
Yes, I'm here. I'm just unmuted. Nathan, are you here with us now?
Yes, thank you very much.
Okay, I'm
Hi,
switching the screen. Thank you very much, Eureka.
Super.
Okay, that's your turn then, Nathan.
There we go. Super. Well, thanks very much. Hello, everyone, and welcome. So, yeah, my name is Nathan Carver. I've actually been developing software for a while, having actually had a career as a circus clown before this, but that's actually another story. What it means actually for me and for my work with Edison is that I actually have fairly limited experience in hardware. I've built projects before with PIC microcontrollers and of course Arduino. And my Arduino experience and my electronics there were getting pretty good. But getting things online was always a problem for me. So, I mean, there was the time I bought a Wi-Fi to connect to the internet and realized that I would have to write my very own web server from scratch. So there was a lot of difficulty there, and I still wanted a community like that, a big community like the Arduino community, but with more straightforward support for IoT projects. So when I heard that Intel, that the Edison supported Node.js natively, I had to go to the hackathon that was here in New York City. It didn't matter to me that it was a new product back then. that Intel was still building their developer community around Edison, because I knew that the Node community is just super strong. And that would mean for someone like me, who's strong in web development, that I could feel very comfortable programming what had been for me very difficult online projects. The focus for the Edison on size and a single Wi-Fi setup meant that this was a platform for IoT, which had really been an interest for me. And I wanted to build projects that were able to hide the hardware and make things in the home come alive in new ways. So TEETH stands for a timer encouraging everyone to health. And this here, the picture on the bottom, is how the project looked at the hackathon. You know, to be very simple about the technology, it's a timer connected to the internet. And I'll show a video next of a demo of it. But you know, with the Edison platform, I was able to build the prototype in really, truly less than a day. And it was also familiar to me, right? The Intel SDK is pretty good. Their XDK is what they call it. But I could also work in Sublime, just like all of my other JavaScript coding. So it was literally minutes with no programming, no writing my own web server to get on the Wi-Fi and be on the internet, adding the device sensors, even the LCD, which has always been sort of a problem, kind of a chore. It's well documented in the Intel templates. But I knew that this was a platform for someone like me when I wanted to add an email feature, because I simply did a require to an existing Node.js library for SMTP. And in a few minutes and 4 to 5 lines of code, I was sending email. So, so that was just incredible for me to be able to take a hardware device to the internet, add features quickly. I'll show a video here of TEETH.
I guess you had a lot of fun, Nathan, doing the video. It's quite good. Well done. Well done. You're a great actor, Nathan. Very interesting. You already have several questions.
Good. Thank you. I'm not sure how much time I have left, but just in terms of next steps, Intel has been super about helping me sort of re-envision the project beyond just the technical. They have a lot of resources to look at, things like even product story and bill of materials, potential revenue. So that's out there for any entrepreneur. And it's meant that I've started to concentrate on other bits, making sure that I can concentrate on the web services behind the social interaction. But I wanted to provide this link here for anyone who's interested in building their own version of Teeth. I've posted my original model up on Instructables, and you can always use the forum feature there to get a hold of me if you have questions, or to work through the folks at Be My App at Intel. So thanks very much for listening, and yeah, I can take a look at a couple of questions here. Folks asked about a wall plug and a battery. So in this picture, I think you can see in the bottom the black square there is a battery. So that was my sort of original. The battery is a rechargeable. It's one of those that you would use to recharge your phone. And there were a couple of problems with it. One was that it gives about 4 volts, and I really needed 5 for the screen. And the other was that it lasted about a week, and I wanted a little bit more. So in some newer versions now, I'm looking at a wall plug instead. But the Edison itself was able to work off of that rechargeable battery for actually quite a while. I think it was really the screen that was taking so much energy from the battery.
Great, thank you very much.
Yeah, thank you very much for giving me a chance to present.
Well, thanks to you. I have to say you're a great actor, Nathan. Seriously, your acting is really good. So indeed, as you were reminding to everybody, feel free to get in touch with the speakers. Okay, they have several Instructables. Round of applause. Yes, thank you very much, Ludovic. Asking a round of applause for you, Nathan. So I'm directly going to head to Patrick. Patrick, are you here with us?
Yes, I am. Can you hear me?
Oh, yeah, we can hear you well. I'm directly sharing the screen
Okay.
with you now, so feel free and go ahead. The crowd is well excited after Nathan's presentation, so you can go ahead.
So this is about my project, which I call Edison, which is controlling a Robo-Sapien from the Intel Edison. So I'll just bring the intro page, and actually I should introduce myself as well. My name is Patrick Morris-Suzuki. My professional life is I've had a career in finance as a quantitative analyst and a software developer, so very different from this. And I'm actually taking an hour off work to go to a cafe to present this, so apologies for the background noise. But as you can tell, this has nothing to do with finance. So the Robo-Sapien is a low-cost humanoid robot, and it has bipedal walking motion, and it's infrared remote controlled. And so when I saw it, I thought, and also the Edison, I thought finally we actually have the hardware to make cheap toys of the kind that you might have seen in Toy Story. And I also listed some more some other movies, Child's Play. Well, this isn't really like that, but some of my colleagues thought it was like that. And the one that my kids thought of was Five Nights at Freddy's, which is a independent computer game that's very popular with kids. So they named my bear Freddy Fazbear. So some of you may know what that is. Anyway, these are just some of the popular cultural references to intelligent toys, and they haven't really come about yet. The RoboSapien provides the ideal hardware in terms of robot mechanics, and it's really cheap, but it's not, it's not programmable. So the next component was an IKEA Vandring Bjorn, which is Swedish for walking bear, apparently, teddy bear. It's very robust. It's very cheap. I paid $15 for it. It's large enough to hold a RoboSapien, but the stuffing in the head is a little bit heavy, so I had to replace it with packing peanuts. So maybe I will show you a quick video to see what we created out of these in the Edison. Sorry, this is better. Okay, so here we're sending a remote control command. This is the high five command. Sorry, I think his head needed to be attached a bit more tightly at the back. And then we're going to send a walk forward. And then we're going to send a walk back. And then we're going to send a swipe right, which is one of the little robot martial arts commands that's programmed in. So anyway, back to the presentation. So this is the Intel Edison, of course. I actually kept the packing box you needed for this project, and it's in the Arduino breakout board. You could probably now do this with SparkFun blocks, but they didn't exist when I was doing the project. I also did it at the Intel IoT Roadshow in New York. An infrared LED and resistor hooked up to the pins on the Arduino. The instructions are all one-instructables. It's solder-free, so we're just using jumper wires to connect the LED to the Edison breakout board directly. So the software is kind of interesting. So one of the things that the Edison has is an Arduino, say, compatibility mode. So you can run Arduino sketches on the Edison. But what's interesting is that sketch environment is actually very powerful, and it allows you to do things that you could never do on an actual Arduino. So keep in mind that even though you're writing in C, with Arduino libraries, you have the full power of Linux underneath you. So in this case, we used it to call the shell commands to communicate with Firebase, which is an easy-to-use real-time cloud database. And so the back end doesn't require any coding. And the front end, so I have that web interface you saw. All it does is it saves a command integer to Firebase, and then the Intel Edison retrieves it in the Arduino event loop. So this is the example of what the software looks like, right? So this looks like Arduino code, but you see this line here that says system curl, and that's a curl command to retrieve a path which has a command and save it to a temporary text file. And then we start reading it, just check that we can access the file, check that the file is of the expected size. We then to convert the command to an integer, so the string to an integer, and then we send the integer to this send command line here. Is the command to actually use the infrared LED. And then we send another curl command to erase the command from Firebase, so we don't then do the same command multiple times. So as you can see, none of this would actually work on an Arduino because the shell command is not going to work. But then the rest of the code is more or like classic Arduino sketch code. So send command sends a header, and then sends ones and zeros. The header 1 and 0 all consist of sending pairs of a different length of a pulse and then a space. So a pulse is where you modulate at 38K frequency, and the space is where you don't send anything. And then this is a tight loop that will send the infrared, modulated infrared at the right frequency. So hopefully that kind of explains what we're trying to do. I just point out a few things on this code. I don't know if this is still necessary, but we needed to do the timing via a tight loop, so we would just literally spin the CPU for the timing for the infrared, because infrared modulation requires fairly precise timing, and people actually told me that that they didn't think it would work, but it worked just fine. So I'm quite pleased about that. We use the delay microseconds for the off pulses because their timing is not as critical. So that is the end of the presentation bit. Let me see if there are any questions.
Hey, Patrick.
Hi.
All right. Thank you very much. Looks very impressive. I like the high five command. This is
So I think the point I kind of wanted to make about including the coding details is that if you would like to use existing Arduino libraries, etc., you can do it, but integrate it into a connected, into a connected device very easily. So, using obviously the built-in Wi-Fi and also the ability to access the Linux shell directly from an Arduino sketch allows you to do things that would be quite inconceivable with a regular Arduino. So it allows you to take something that was a traditional Arduino app, if you will, add cloud connectivity very easily. So I know this isn't perhaps the normal way that people do cloud-connected Edison apps, but I think it opens up the world of existing Arduino code to the Internet of Things very, very easily.
So thank you very much. If you have any question I'm addressing right now to the audience, feel free to type them on the question panel, okay, on the chat panel for you. Thank you very much, Patrick.
Thank you.
Was very interesting as a Nathan project was. So we are now approaching the end of this webinar. Just to let you know, there is all this webinar has been recorded. Okay, so it will be displayed on YouTube, and we'll send it to you through email. Just before leaving, Patrick, there is a question for you from Ludovic on the chat. So I'll let you type down the answer. So interesting project, the Edison teddy bear. So also, we just wanted to share with you that there is another upcoming Intel IoT webinar on Edison platform. Okay, it's going to be on May 5th. Yes. So basically, it's exactly the same format. Half an hour sharing experiences about individual and independent, projects. So it starts at 6 Paris time. So we'll very soon send you the invitation. Probably tomorrow, Beatrice will send it to you. Before leaving, Yorick, are you still here with us?
Yeah, I'm still here.
All right. Do you want to share feedback or say a goodbye word to the whole crowd?
Not sure if you can see my screen, Alex.
Now we can. Yes, indeed.
Okay,
if you have
thanks.
some.
Yeah, just wanted to thank again Nathan and Patrick for showing what they worked on and the full process behind it. I just wanted to close here with 2 references for more information on this. The first one is our Edison online community, which is maker.intel.com, and you will find all the information on the product itself, how to get started, and also a community of people who have already hacked on Edison, sharing ideas and projects they've already built. And the second one is our Intel IoT Developer Zone on software.intel.com/IoT. So this is where you find more of the software information and all the development tools to help you get started on platforms such as Intel Edison. So that was it. Thanks everyone for being there and participating to this webinar. And with that, bye for now from my end. Thanks, Alex.
Thanks to you, Rick. Thanks to everybody, and see you on May 5th for the second edition. And as I told you, we'll send you the recording tomorrow. Thank you very much, and see you at the next webinar. Bye-bye.